here. When two things are related in such a way that the ratio of their values always remains the same, two variables are said to be in direct variation. Yeah, I know. What? We'll take a look at an example of this. These are important things to know. Y equals kx is our model for what a direct variation looks like. What does this look a little bit like? It sure does. It looks a little bit like y equals mx plus b. Except, what do I know here? What is m? Okay, m and k are the same thing. And what's b? Zero. No, nothing, zero. So k is the same as m, and b is 0. K has a special name in a direct variation. We call it a constant of variation. I don't know why it's a K instead of a C, but we can't spell. It could, but they don't do it. You could call it y equals mx and say it's a direct variation. You absolutely could.
Oh.
We could. But K reminds us that it's called constant of variation. But whatever variable you use, this thing in here is the constant of variation. It's also the slope of the line. They are the same thing, but let's kind of see it as an example. So this is important. On Earth, something weighs 150 pounds, Earth pounds. Now on Neptune, the same thing would be 165 Neptune pounds, I guess, or maybe our pounds, I'm not even sure. I guess our pounds. So, how did I get from here to here? Well, that's not how I really got there. How did I get there? What did I multiply by?
X.
I did by x. What's x? I took 150 and multiplied it by some number, and I got to 165. Well, x is not k. Let's not get ahead of ourselves. I just want to know what x is.
4. 15.
How do we find x? Do we? We could try yelling out random numbers. How'd you get that, Ishan?
I divided it.
Okay. This guy says, let me solve this equation. 150x is 165. So I divide. Whoops. And then he said, well, I'll just put that through my calculator. 165 over 150 is 1.1. So that means the way, this is kind of like a factor. The factor you apply to an earth weight to get a Neptune weight. So let's suppose Kingsfield is about 10 pounds. I would like to know what he would weigh on Neptune. Here's what he is on Earth. So how would I find that? I multiply by that factor that we just found. That this is anything on Earth, to get to Neptune, you multiply by 1.1. So I guess Kingsfield is 11 pounds on Neptune. What if, I don't know, what's a 200-pound thing?
Me?
I don't know, not you. What, 200-pound weight? Okay, we have a 200-pound weight, and we want it on Earth. And we need to get it over there to Neptune. We want to know what it's going to weigh on Neptune. How will we find that out? I could do that, but I might have a little bit of a hard time getting it over to Neptune. So how can I find it without going all the way to Neptune? I have this factor here that tells me, you know, what it's going to weigh. So this thing here is the constant of variation, because it's the constant that we multiply to get from one variable to the other. Oops. Constant of variation. So yes, it is a constant of variation, but why is it a constant of variation? Because that's the thing, I use that number every time. And yes? Well, because I already know one situation. If something is 150 on Earth, it's 165 pounds on Neptune. So that means, and Ishan helped us figure this out, that I had to multiply it by 1.1. That's how you get there. So anything, that means, oh, so this is the thing you multiply by. Not the same. So, like, do I add 15? Does adding 15 work? No. It's a multiply. It's a multiply. So this says, well, what is it? It's like, what factor do you multiply by to get there? You multiply by 1.1, and it's the same every time. So this desk weighs, I don't know how much that desk weighs, 8 pounds? I don't know. If it didn't, I wanted to know what it weighed on Neptune, I don't usually do that. It would be, whatever that is, 8.8?
And so for everything, it's multiply by 1.9.
Same number, exactly. For this situation, now we say that Earth and Neptune vary directly. They have a direct variation because this is that ratio the definition was talking about. You multiply by the same number every time to turn an x into a y, right? To find the x finds its matching y. Whoops. So if an object weighs 200 pounds, we do that. It's 240 pounds. So the idea is this is a direct variation. That same number is applied to an x to get a y. So let's go here a little more general. Y equals kx, y equals mx plus b. We did this already. K and m are the same thing. The constant of variation is the slope if you were to graph it. And b is always 0. B is always 0. I'm right, Mister. What should we be doing?
I'll write it.
That's definitely right there. Anywhere? Take out another piece of paper if you need it. B is always 0 for a direct variation. The y-intercept is always 0 for a direct variation. So if I was to graph it, what point do direct variations always go through? 0, 0, the origin. So if I want to graph this, now is this a direct variation? How can you tell? The y-intercept is 0. What's k? 3. What's m? 0. M. Yeah, now m and k are the same. Compare to y equals mx plus b. They are the same. So if I want to graph this, my b is 0, right? So that says go to 0, your y-intercept. My slope and my constant variation, same thing, 3. I'm going to go up 3, right 1. 1, 2, 3, 1. I can also go down 3 and left 1. So graphing them are just like graphing any linear equation, but you're always starting at the y-intercept. Yes, ma'am.
So it's y equals mx plus b and y equals kx.
Yeah, they are, because they're both linear. Except what is b for any direct variation? 0. 0, so I don't have to put it there. So what's the slope? We did this already. And what's the y-intercept? So graphing them is no different than the other graphing practice we just did. It's just it happens to be always you're starting at the origin. That's all that is. What else we got here? How can you tell if something is a direct variation? So you're going to compare to y equals 3, kx. So anything you get, put it in slope-intercept form. Y equals mx plus b. And as long as my b is what? It's a direct variation. 0. So we can look at some examples here. So if I have y equals 4x plus 2, what's the b, the y-intercept? 2. Because y equals mx plus b. So is this a direct variation?
No.
Why not?
Because it has a border of 0.
Right? It's not 0. In order for that to be, right, it can't be picked up 2. Then this doesn't apply. There is no constant of variation because it's not a direct variation. So I don't have to answer that question. Now I've got this example, 2x minus 3y equals 0. Well, hard for me to tell what's going on here until I put it in function form. And what does that mean? Solve it for y. Let's do that up here. How do I solve this for y? Show me. Who's going to help me? Katie, how do I do this?
You have to make the 2x go away.
Yeah, I'm going to make that 2x go away.
Subtract the 2.
Subtract 2x. 2x minus 2x is gone. And 0 minus 2x is minus 2x. Solving for y. Divide, because I want 1y. So I divide everything by negative 3. What's negative 3 over negative 3? 1y. Negative 2 over negative 3, I don't want to write that in simplest form. 2 over 3, because a negative divided by a negative is a positive. So there it is in function form. All right, now we're going to compare this to y equals kx. All right, so what is the y-intercept here? So is it a direct variation? And doesn't it look like y equals kx? What's k? 2/3. Right? 2/3. It's the slope. K and 2/3. So you can just line them right up. You can see what k is. Yes? You two, you try these other two, right? You've got a C and you've got a D. You try them. Take a look. Yeah.
So you basically just write it down, MX is the thing of like,
Yeah, y equals kx is. Yeah, y equals kx is y equals mx equals b, isn't it?
yeah,
The difference is b is 0 and k is x. Listen, I could have called that m. Why keep forcing that? Why don't we just call it m? We could. We could. So let's see. This one you should have added x to both sides, right? Solve it for y. Why do I put the x first in front of that? Why? I could have written 1 plus x. That's correct. It's mathematically correct. Why did I turn it around? Because I want it to look like mx plus b. So what is b? So is this a direct variation? Why not? Why not? The b has to be 0. So this is not a direct variation. It's a perfectly fine line. It's just not a direct variation. Now this one we have to solve for y. I subtracted 4x from both sides. So I'm getting negative 5y equals negative 4x. We're going to divide by negative 5 to get y by itself. So y equals negative 4 over negative 5. Positive 4 over 5. Is this a direct variation? Yes. How come? And what's k? My constant of variation is 4/5. So this could be, I don't know what the direct variation here is, but maybe to go to Earth to Mars, maybe you multiply by 4/5. I don't know. So it's something like that kind of a relationship. Yes, right? Y equals kx. So there's your k. Finding the constant of variation now. How do you find it if you have like a line? And there's a couple of different ways to do it. 2 different ways. So you always start with this. I hope you're going to be writing this a lot as you're doing this homework and stuff, because we need that in our brains. Now what you can do is find the point on the graph. Not 0, 0, but another point on the graph. So where is there a point on the graph? Oh, here, they just gave us one. There it is. Now what we're going to do is we're going to kind of line it up. So this is x and this is y. So 2 equals k times negative 1, right? How do I get k by itself? Is that how you solve it? Is it? Yeah. Okay, so what's k? Excuse me? What? How did k get to be 1? What's 2 divided by negative 1?
Negative 2.
Negative 2. So my constant of variation is negative 2. This version. The other thing you can do over here is you can remember that k and slope are the same thing. Can we find the slope of this line?
Yeah.
I'm going to use these 2 points because 0, 0 is always a point. Let's go down 2, that's a negative, and go right 1. Is the slope negative 2? And so is the constant of variation. So there's 2 ways right there to find it if you're looking at a line. Now another way to do this, which I think is the easy way with direct variation, is I say, where's my point again? It's over here. Well, if y equals kx, can I solve this thing for k? How do I solve this for k? I want k equals. Divide by x on both sides. So here's my big one, and I'm going to just flip them around. K equals y over x. Right? Who followed that? We followed that? Why is k y over x? I just solved for it. If y equals kx, then k equals y over x. Yes or no? Okay, so I have an xy. Right here's an xy. There's an x, there's a y. So can I just say k equals, well, what's my y? And what's my x? -2. So if you have a point, a coordinate pair of a direct variation, it is very easy to find here. Easy. Boom. You're very easy to find the constant of variation. Y over x. I'm looking at y'all and it's like, once it clicks in. So I'm going to do a different one. What if I had some other one? I don't know what it is. And here's a point on the graph. Oops. Why is this not a direct variation? Well, let's now let's go through the origin. Can I find the constant of variation? Yes, sir. Yeah, how'd you get 5 over 3? K equals y over x. I've got a y and an x. 5 over 3. Now, what's the equation that goes with this? I'm talking about this. Okay. So what is the equation of this line? What's K? Yes. That would be the equation of the line. Yes. So for some reason, this becomes the most confusing thing ever when all we're doing is I have a model. And if I can find K, like I did with Earth and Neptune, I've now got a function that I can use for other examples of x's and y's. So you find K by using an example, y over x, and then you just plug her in. Once you've found K, you have the equation of that line, of the direct variation. Yes. What? Oh, so this was on the other line here, and I did it up here. So you would put the 2 here and the -1 here, and then you solve for negative, take the -2. Yes? All right, ask me a specific question, because I never know why this is hard, and every year it's hard, and I never know why. Yes? I don't know.
Why?
Oh, yeah, why is it? I solved the equation, right? Don't you divide both sides by -1? Why? Because to solve that equation, you divide both sides by -1. We're just solving the equation. Another example, huh? I'm not. Okay. So I'm going to just draw a graph. Wow. Oh, pretend it's trying to go through the origin this line. So is this a direct variation? Yes. I'm going to pick a point. Okay? This point is on the line, right? Is it a direct variation? Yes. So I know it's going to look like this. Well, how do I find the K? That's what's missing. So I say K equals y over x, because doesn't it solve to divide both sides by x? And then what's y? And what's x? Which is -1/2. So what's my equation? An equation has a y and an x in it. If you don't have a y and an x in it, you haven't given me the equation, right? Those are my variables I'm working with. And then what's K? You just told me what it was. So it goes up here where K goes. The slope. It goes right there. Better, not better? Yes. Slope and constant of variation, same thing. Same thing. So find the slope, it works. And doesn't it work if this is 0, 0? -4 minus 0, no, the slope is not 2x. Let's use the formula, right? 0, 0. -4 minus 0 over 8 minus 0 equals -4 over 8 and -1/2. Because it's 0, 0, you're subtracting zeros. That's why y over x works. You're changing this, you're always just subtracting 0 out of it. Let's see if we can move on just a tiny bit. Okay, so I've got tables now. These are tables of values, and I want to know if it's a direct variation. So a direct variation looks like this, right? K is the same for every xy pair in a direct variation. K is the same. So remind me how I find K. What was it again? So I find K for all of them. If I do y over x for every pair, to be a direct variation, what would have to be true about the K's that I find? They all have to be the same. So what is y over x here? 30 over 10, right? Which is, what's y over x here? What's y over x here? What is K? Is this a direct variation? What's the direct variation equation? Yes. So when I'm asking for the equation, I'm looking for this, but with a value for k. So you have to find k and plug it in there. And why is it a direct variation? This is k. It has the same constant variation for every point. Let's see if this one is a direct variation. Let's find k. What's 5 over 15? 1/3? Right? 5 over 15 is 1/3. 26 over 3 is 26 over 3. 75 over 1 is 75. 150 over 2 is also 75. Is this a direct variation? No, why not? Right? You have to have the same constant of variation for every point. So that one is not. What's over here? Y over x has to be the same for every point. And so, yeah, you find the direct variation. Once you find k, you plug that k into y equals kx. Let's see, we got some other examples here. We got a couple of tries. I don't think we're quite ready to fly solo. I just want to do a couple of these. Now, how do you graph y equals 2x? What's the constant of variation of this thing, first of all? What's the slope of this thing? 2 or 2 over 1. So, let's see. I need a y-intercept, don't I? And the slope is 2 over 1. Up 2, right 1. So start at 0. What do you do? Up 2, right 1. Or down 2, left 1. So is this graphing any different than what we just did last night? No. That's it. So graphing is the same. Yeah. Because it's y equals kx. K is my constant of variation. Constant of variation and slope are the same. They are the same. If you haven't written that down yet somewhere, write that somewhere, a circle of stars. They are the same thing. Don't let that be the confusing part. I like this question. The graph of a direct variation passes through a point. Can you make this line? Because what's another point? 0, 0. And 4, 6 is over here someplace. So if we want to see what it looks like, sometimes that can help us. That's what we got. Can I write the equation that goes with this? Let's start with the first part. Write the direct variation equation. Well, I know it's going to look like this. Well, what's k? Yeah, why is k 6 over 4? K is y over x. 6 over 4, which is 3 over 2. So, Emma, what's my equation? That's it, exactly. Perfect. Tell me y equals 3 over 2x. Yeah, we'll get to that part, but did we get this part? Yeah. Questions on this part. You find the k by doing y over x, and you plug it into y equals kx. That's all you're doing. That's all you're doing. Now it says, find the value of y. So I've got an equation now. So if x is 24, what do? Plug her in. So what's 3 halves times 24? Well, let's see, I can reduce that, right? So I get 36. So when x is 24, y is 36 in this direct variation, because I'm going to apply the 3 halves to the x. I see a lot of perplexing faces. Question. Don't be tired. No, it's only Friday. Why are you tired on a Friday? It's only been a really long week. No reason for it. All right, now, how can I tell if this one here is a direct variation? What should I do? Tell me process. Okay, what should I do first, Alice? Right, because that's k. So 25 over 10, you get 5 over 2. Okay. No, it's going faster than I can write with this thing. Okay.
Over 4,
Yeah.
5 over 2.
Okay.
Because
So is it a direct variation? Why? K is the same for all the points. What's the equation?
y equals I over 2.
Excellent. Yes, ma'am. You got it right away. To find the constant of variation, every point has to have the same one in a direct variation. You find the constant of variation by doing y over x. So that's what we did here. We said 25 over 10 and we reduced it. We did 15 over 6 and we reduced it. 10 over 4 and we reduced it. 5 over 2 already
It's
reduced.
just there.
So look at them. All the K's are the same. So I know what K is. And once I know what K is, finding the equation is simple. Because y equals kx, I just plug it into the K position. Right there. And that's it. Now what if there had been another one here? 311. How about that one? So would this be a direct variation if that had been there? No? So do you have to check all of them? Yes. Yes, you do. All right, question? Okay. So, yes, as we know, life is a word problem. Nobody comes up to you and says, here's 2 and 5, and I think they're a direct variation. Can you tell me the equation? Nobody's doing that. They're saying, I've got this huge problem. I'm trying to set up my saltwater fish tank. Anybody ever have one of those things?
I have fresh
I
water.
have we have a giant fresh water.
Well, we want salt water now. So we're getting these creatures from the salt water, the ocean. So it's telling you the number of tablespoons. Excuse me, I'm okay. Don't worry, I'm okay.
Okay.
The number of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number of gallons. I'll be right with you, Gary, okay? So varies directly. So what you want to do is you're going to zone in on that. You're going to underline it. You're going to circle it. You're going to do what you need to do to make sure you understand. This is a direct variation we're talking about. Word of caution, there are other words that mean varies directly. You might see varies proportionately. There are other words that mean the same thing. And then you have to figure out, well, what's varying directly with what? So let me read it again. It's saying the number S of tablespoons of salt. So it's really the salt is varying directly with the number W of gallons of water, right? So let's see if we can read this more simply. Salt varies directly with water. I'm making it as simple as I can. Now the words varies directly translate from English to math to equals salt varies directly with water. Do you have a question, Gary?
So, the gallons of water is X.
All right, let me go through it, okay? Because I know you see it. I know you got it. So let me just go. I'm going to go through just a tiny bit slower. Salt varies directly with water. Are we okay with this? Yeah. I'm basically just interpreting the question. So I'm not using Y and I'm not using X. I could. But the reason I'm not is because I want to remember which one's salt and which one's water. Because these are proportions. They are proportions. We have to kind of go in the same way. So let's see. What do I know? 100 tablespoons of salt goes with 20 gallons. So I'm going to look at the salt that says 100. And then the W is the 20. Now what did I just do here? I plugged in. I basically said, like before we said who's the X, who's the Y, and we could figure out K. I'm kind of doing the same thing. Because what's K going to be? So this is like the Y over the X. My K is 5. So what's my equation? Go back up here. What's my equation? Working with these now. S equals K. What's K? W. And if you said Y and X, that's fine. You just have to remember that Y was the salt and X was the water. So I personally think it's easier to give more meaningful variables when you're doing the word problem. Because that's how I know to put the salt here and the gallons of water here. So by using these labels. I now have a general equation. Then it says, well, how many tablespoons of salt do you need if you have a 30-gallon tank? So I'm going to use this. I've got the equation now. So is that 30, is that the salt, or is that the water? That's the water, right? I'm going to put it there. So S equals 5 times 30. S equals 150 tablespoons of salt for that many. Now what if they said, I've got, come on, I'm trying to think of a good number here. 90. I've got salt, and I've only got 90 tablespoons of salt. That's a silly example. Okay, what's the maximum gallons I could use? Gallon-sized fish tank. So that would be, well, I know the salt, but I don't know how much water. So what would it be? 18-gallon tank. Right, is 90 gallons part of everything? Yeah. So I can go either way now. Now what if it says, well, what if I have a 50-gallon tank? 50 times 5. So I have a general rule now because it always varies. It's 5 more than the gallons of water. Okay, so that's a word problem. So I don't know if that's kind of where some of you were getting at, you were asking. Let's look at another, what? Well, is this hard? Can we just figure out what's varying? Figure out what is varying directly, and then you work it through. Here's another example. This is, the table shows the cost, see, so this is the cost of downloading some songs from an internet music site. Not iTunes, because I can't use, a music site, a very general one. I don't know why I can't just say iTunes, but I guess they don't pay me enough or something, I don't know. So you're downloading songs, right? It says, explain why C varies directly with S. Well, does it? C varies directly as equals K with S. So what would that mean? What's K then? Is C over S. So let's see, do I get a consistent K? What is C over S? So let's try it. C over S. What is 297, right, we're talking money, divided by 3? What is 495 divided by 5? What is 693 divided by 7? Okay. So that is the same, right? 0.99 to 99 hundredths. So are my K's the same? Yes. So what is the direct variation equation then? What if I wanted to download 10 songs? Which is what? $9.90. Now what if I go the other way? I've got $10. How many songs can I download? So that's your C. Right? And you would divide here. Well, what is it? Well, can I download 10.1? How many songs can I download? 10. So it helps me. Now I have a rule. Now I've got a rule based on this direct variation. Okay, so that's what we're going to be working with. I wish I had another example here. This is a summary. Direct variation y equals kx. Solve it for k. You get k equals y over s. So if I have 2 points, which is what you're doing in a word problem, they give you 2 points. You find the k, and then you apply it, and then you graph by using the origin as one of your points, and then that k is sloped. So you can graph them that way. If you have a table, and you want to know if the table of values is a direct variation, you use the y over s, and say, are all the k's the same? Right? So that kind of sums it up a little bit. I'm trying to think of another example of things varying directly. Let's do this. I don't know if it's going to work, so let's try it. The taxi. The cost of your taxi ride varies directly with the miles you travel. Okay. You went 10 miles, and it cost you $20. What's it going to cost to go 15 miles? Okay. Getting the answer is not the, well, I mean, it's a goal, but I want to go through the process here. I want to review process. So I see cost varies directly with miles traveled. So what can I start with? 15 miles. Thank you. So how do I start this? See, cost varies directly with miles. Cost varies directly with miles. So I've got my model. All right, now this is 10 miles. So is that the C or the M? Right? And how much did that cost? $20. So what's K? So let's rewrite this equation. C equals what? 10 times N. Okay, so what's it going to cost to go 15 miles? That's pretty good. That's 2. basic steps for doing a word problem with this. Okay. Questions? So,